let's go with Kevin Samuel. Kevin, are you there?
Yeah, you hear me. Hey, Jaron.
What's up, how are
Am I echoing? Or is it?
Good enough.
Okay, so I sent you on Telegram, I sent you 3 pics. I like to set up an experiment of the first mechanical falsification of curvature. So you maybe heard of Jaron's, or not, of Dave Weiss' idea to pull a rope with 2 boats in 2 opposite directions, but he thought it's not possible because it will sag. So I thought, let's make it in water. So if you do this in water, then it won't sag that much, and you don't instead of using boats to pull a rope, you can use a rope winch.
And this has been discussed before. They've already had people try it too. Either the line is broken, or you're going to have a neutral buoyant fishing line, right?
No, you can have steel wire. Like you don't need the fishing rod. You can have something more stable. And when you have, you can either use how is it in English? Swimmers, that you equalize that it goes up again. So
right. So let's say we winch both sides, or we bench one of the sides, and the line just lays on the water, and it's got little bubbles there, little buoys. So the Globers will just say that it didn't go into the water because of the buoys. How are you going to prove that that's not correct?
Yeah, you have to use the right amount of those buoys, or you use a rope which has already the same buoyancy, like something a mantle of plastic.
Yeah. So that was the problem, is that we kept getting to the point where we would say either they're going to say that, because here's where you have to falsify something, right? So like, if let's say for example that we get there, we do the test, and the line pulls through the water, right? But on that line is like weights and buoys and things. You don't think flat earthers are just going to say, no, it went under the water because it has weight on it?
You use every 5 meters you can have a buoy.
So if you have, hold on, just think what you're saying. So if there's a buoy every 5 meters, 15 feet across 2-3 miles, how would that not be an acceptable answer for somebody on the globe to say it didn't go into the water because you have buoys every 15 feet?
Because it's not the big buoy. It's this little swimmer which.
Yeah, I've seen little red and white things, right?
Yeah. But I'm rather looking for a better material, because I already did the calculation. You probably don't even need this. It's 1,800 Newton to pull a wire of a steel wire, and you can achieve that. So it's not necessary. So when we to use buoys at all. So we can pull this, and when we achieve, it's on 3 kilometers. How many miles? It's 17 centimeters in the middle. It's like a little bit more than this.
Okay.
Difference. So when we achieve this, it's already on the globe. The globe has an advantage if it sags, or so if we achieve to pull it well, then it's proven.
What name are you on Telegram? I'll find what you sent me.
I think Kevin Samuel.
Oh, let me see.
I sent you 2 pictures of boats now. The difference between globe and flat, and I sent a picture of how we could entangle a rope winch. So you use a weight.
Okay, here's your globe on the screen if you want to explain it to people.
Maybe Kevin Bo or Kevin Samuel on Telegram.
I already got it. It's on the screen.
Kevin Bo gone, maybe.
Yeah, it's on the screen. Go ahead and explain it.
Okay. Wait, there is the how can I
the globe
make
model
this big here again, because I don't see it myself. No, I can zoom. So the values are a little bit off. I used a better calculator afterwards. So this is still the boat example, left and right. Let's pull it with a rope. The bulge is the water surface, and if we pull a rope, it will. If it's a globe, it will be horizontal, and you will have this middle portion of a difference. There it's written 30 centimeters, but it's 17 centimeters. So 7-8 inches.
Over 2 miles? Or how many?
Over 3 kilometers. How much is 3 kilometers?
It is 3 kilometers.
3 kilometers.
3 kilometers to miles. I don't know that equation off the top of my head. 2
yeah,
miles.
Maybe.
It is 1.86 miles.
Yeah.
Well, over 1.86 miles, the Sagitta would be like 3 or 4 inches.
Yep.
Right?
Yeah, 17 centimeters. So this is you can have pressure sensors on the rope, which can measure very well. So you can also dive along this thing, and put the last picture, because a boat would make too much noise. It would give too much waves.
Agree.
So better have a rope winch and put the weight underwater, and so it will have so it's better to have a lake or that you don't have so much noise, but you only actually need one rope winch, 1,800 newtons. I can send the calculation also on Telegram.
Yeah, and I have the Sagitta as 6.92 inches over 1.86 miles.
Yeah,
So,
this sounds measurable, right? Because you and you.
Yes, I think so. But I think yeah, I mean my original thought was 3 miles, because the 3 mile the Sagitta is 1.5 feet, 18 inches, which is much easier.
Yeah, but it's too much of rope. It's well, it's not that expensive. You can have it for I looked it up, $1,500.
Yeah, I think you can go less than that. But okay, let me go up with your next one here. You've got next the flat one, but
yeah, this is the flat comparison then to it, and yeah, this is obvious. Flat is flat, and we don't have this difference.
Okay. And if it did sag a little in the middle, we were just hoping it would hit the water and just float.
No, it's not above the water from the beginning. It's on exactly on the water, which helps that it won't that the sagging is not a problem that much, because the water has more density. It will be exactly on the surface, yes. And if it's a globe, it will go a little bit below this some inches, and right. If not, it remains exactly on the surface.
Okay.
It's better with the density of the water to support it.
Okay.
Yeah, and to put the last image to show the setup, which is more probable to achieve in reality. Can you turn it? It's actually.
Oh wait, yeah, I can. Okay.
Yeah. So there's, if you have a rope winch on the shore or of a port, when you have a harbor, you have these big rope winches. You need just to find someone who will allow you that.
Right.
And put the like you need 100 or 200 meters of a slope, and then put the weight in the water on both sides. Okay. And you got it.
Gotcha.
Yeah.
Why did you say we have to have? Where'd you get this 200 number from?
To have a little game, a little play from because the middle portion is 3 kilometers, so you need a little bit
okay, so
stable setup.
And we would just be measuring from G to G there.
Yeah.
Okay, gotcha. Okay.
Yeah, so I'm thrilled to do a mechanical setup, because no reflection bullshit.
How can people follow along, and if they want to be involved, that kind of thing?
Yeah, I will write in the Telegram groups. I post in Miswits, but I will post in your group. Maybe I will make a GoFundMe for the rope. And,
okay.
Yeah.
Yeah, you might want to talk to Mitchell from Australia. He tried this already and he gave up on it for some reason. So I want to check with him what his big hang-up was.
Okay. Yeah.
Yes.
Perfect.
Alrighty. Anything else for us?
Oh no. This is my thing now.
This is your mission in life?
This is my mission for the summer. Let's see.
All right. So when you plan on getting done this summer?
Yeah, let's see if everything works out. I will look for a place to do it. We have good calm lakes here in Austria, in Europe.
Okay.
Maybe there's big lakes, calm lakes. So I just need to find this rope winch and speak to the port.
All right. Well, thanks for calling in. Thank you for Arnold Schwarzenegger as well.
Yeah,
we appreciate it. All right. Thanks. Peace. It'd be fun to watch.